Hello everyone, Siddharth this side, and in this video we will be solving another question on Geek for Geeks, which is height of a binary tree. So let's see how we can solve this problem. So we have given the root node, and we have to return the height of the given binary tree. So let's see. So suppose this is a tree. Let me zoom first. Okay. So this one, two, three. So suppose this is the binary tree that whose height we have to return. So the approach that we can think of is that first we will traverse to the left of the tree until we will reach the root node, and then we will travel the right, and after that we will take the maximum of these two. So this is the approach, and this is the best possible approach. And if you try to think for some time, you can easily easily you will able to figure out this approach. So let's see if we have a little bigger tree. So this is 2 and 3, then 5. Let's take this. So first what we will do, we will traverse only the left child. So after this we will, after getting the root node, we will return 0 to it. And now after that we have to visit its right node, so which is null. So we will return the maximum of left, right plus 1. So here the height of the left subtree is 0, and the height of the right subtree is also 0. So we will be returning 1 from here. So we will be returning 1 from here, and you can see also the height for this node will be 1. Now we will the as as left call of this parent is uh, has got over. Now it will call its right child, so which is also null. So this will return 0, this will return 0 to it, and here we are already having 1. Now we just have to return 0, maximum of this 1 and 0, and we will add 1 to it. So we will be returning 2 to its parent. Now the left call of this parent has got over, and it is waiting for its left call to finish. Now it will call for the right child, which is null. So we will be having 2 from here, from its left child, and 0 from its right child. Now we will return 3 to its parent. Now this parent is waiting for the left call to get finished. Now it will call to its right child. So it will move, we will be moving here. Now we will be calling for the left child. So after calling, it is null, so we will be returning 0, and from here also returning 0, and we just have to add 1, so we will be returning 1 from here. Now we just have to take maximum of these two, and we will be returning 1. So adding 1 to the maximum, so which is 3 plus 1 is equal to 4. So this is the approach that we will be using in this question. So this is a very simple question. So let's see how we can code this out. So what we have to do, we will be needing a helper function for solving this question, as we will be taking the recursive approach. So int height is equals to, let's call this function as height solver. So we will be passing a node. Now after that we will be returning this height. So let's make the function also. So int gist solver. Now we will be having a node root. Let's define that. Now after that we have to return null. We have to return 0. We have to return 0 as if we will encounter a node root. So if we encounter a null root, because if we call for its left child or right child, they will be null. In that case we have to return 0. So if root is equals to null, in that case we have to return 0. Now what we have to do? We have to call for the left child. So int left height is equals to height solver. We will be calling this function again. So root dot left. Now let's calculate the right child height also. So gist solver root dot height, right. Now what we have to do? We have to return the maximum of these two, and we have to add 1 to that. So let's calculate the let's return that. So return mat dot max of left height and right height. Now we just have to add 1 to this, and this will do our job. So what we will be doing, first we will be making an height, and we will be passing this solver function to it, which will be returning an integer, and it will get stored to this height variable, and we will be returning that height. And in the height solver method, first we will be calling to the left child of the tree until unless we encounter the null root. Then we will be returning 0 from left and right from the both side, and we will be adding 1 to it. So let's see. Okay, so all the test cases have been processed. So thank you. See you in the next video. Bye.